Well, good day, guys. I hope it went well with paper 1. For now, we're going to take you for paper 2, 2011 again. All right, let's start with question number 1 on paper 2, 2011. All right, question number 1 is data handling. Or it says there, 15 members of a basketball team took part in a tournament. Each player was allowed the same amount of time on the court. The points scored by each player at the end of the tournament are shown below. Okay? 27 up to 62. Now the question 1.1, it says, determine the median of the given data. Now, the first thing that we need to keep in mind when you're given data, make sure that it's arranged in order. Is it arranged properly in order? Now, as you can see from this one, 27, 28, 30, the good part of it, everything is arranged in order. But sometimes when you're given a data, make sure that it's arranged in order. Ascending order, which means from smallest to the largest number. Okay, so what we need there, we need to determine the median. Median is the middle number of the data that is given. Now, if you can see there, this data is odd. Why? Because there are 15 numbers. Alright, so the middle number, we take the first 7, the 8th number is the middle of 15. Alright, so that's the median number. Now check there, which one is the 8th number? 42, 100%. So median is equal to 42. Done. Now 1.2, it says determine the interquartile range for the data. Now interquartile range, we are removing the first 25% and the last 25%. That's how we work it out. But now, most of you, there are normally 2 methods of doing it. So let's look at the first alternative or first method. Well, we are familiar with this to say interquartile range is equal to Q3 minus Q1. Now, how do you get Q3? How do you get Q1? That's what you want to deal with. This is the first method. You choose between the 2 methods which one is simpler for you, and that's the one that we're going to adopt. Alright, now to get Q1, Q1 is the first 25% of the data. So it's not 25%, we know it's a quarter. Now n plus 1 term, that's what it means. That's the Q1, right? So n plus 1 term. And our terms, how many are they? 15. So we say 1 over 4, 50 plus 1. Remember, is the term. So it should be like a quarter of 16 is 4. So we are looking at the 4th term. Now from there, which one is the 4th term?
It's 32.
32, that's it. So 32 in the first quarter. Now how about Q3? Q3 is 75%. So 3 over 4 n plus 1 the 10. So which is going to be 3 over 4 16 the 10, which is going to be 12 the 10, right? Which one is the 12th term there?
It's 46.
46, perfect. 100%. So 46. So now Q3 minus Q1, that's the interquartile range. So we are talking of 46 minus 32, which is equal to 40. Okay. That's the first alternative of getting the interquartile range, Q3 minus Q1, and this is how it is calculated in any given circumstance, in any given data. That's how you calculate Q1 and Q3. Alright. So now this is the first alternative. Now the other alternative to get interquartile range. Okay. Let's say alternative 2. Now, you just get your median. First of all, if you look at the data, we have realized that our median is 42. Now, the first half, any number from the beginning to the median, you also find that middle number. That's the Q1. Alright. This one is very simple. So now Q1 there, it will be like, we are from 27 to 42. And now we have said 42 is our middle number. So from all the data from 27 to 41, those remaining ones, which one is the middle there? 32. Alright. So 32 is the half of the other half. That's Q1. Now Q3, you also remove 42. The remaining half from 43 to 62. You now look also for the middle number there. What is it? 46. This is another method. Then interquartile range. Is also 46 minus 32. 40. This is another method. You can just look at the data. What is the middle? Then the other half. What is the middle of the other half? You take the top half. What is the middle of top half? Done. So this is how you get the interquartile range of the data. Now it says there, draw a box and whisker diagram to represent the data. Draw a box and whisker diagram to represent the data. Right. Keep the answers for this one, the one we've done, because we're going to use the same answer. Now, when you're drawing a box and a whisker diagram, it represents, it's called sometimes a 5-digit 5-number system. Alright. So the 5-number system, or the box and whisker, we are doing 1.3. Alright. So now, when you are drawing this, we draw the number line. Okay. Now, on this number line, let's just took a scale from 20 to, or let's say 20 to, okay, 10, 20, 30 up to 100. It's 10, 20, 30, 40, 8, 90. Right. So now, what you need to do there, you take the smallest number. When you are doing, what is our middle number, median? 42. 42. So 42 is somewhere here. Okay. And then, what is the minimum number?
27.
27, somewhere here. Okay. And then, what is the Q1?
32.
32. Okay. And then Q3?
46.
46.
Yeah.
Okay. And then the largest number?
62.
62. 62 something. Alright. So now when you are drawing it, Q1, Q3, like this. And then this is minimum number, the maximum number. And this is our right. This is our median. So this is what you need to show. From the minimum number, what is it? 27, alright? 7. Then this one, 32. This one, 40. This one. This one?
62.
Or 62. So let's check here. So what you are required to show only is to say starting here, minimum number and then maximum number. You need also to show the median. You need also the first quarter, the first 25%, and the last 25%. Alright? That's what you require. So these 5 numbers, the minimum number, maximum number, median, first quarter, and then Q3. Done. That's what you are required to represent here. So we are done with question 1.3. This is a box and whisker diagram that represents. So whenever you have done all this, you get all the marks on this. That's what you need to represent. And this number line. And you need to show these values, 27, 32, you need to show them. Alright. So now 1.4. 1.4. It says there, use the box and whisker diagram to comment on the points scored by the players in this team. Now, we are now using this to comment. What do you need to keep in mind? When you are commenting on this, look at the spread of the data, how the data is spread. And what is it that you use to see that? The spread? You use this. Alright? Is this thing on the middle? It's more to the right. Okay, so how can we explain it? When you are explaining, first of all, you need to show that there is more spread to which direction? On the right. So you need to, on the right of the median. So on the right of the median, this is midway, there is more spread to the right. One explanation. You get all the 2 marks. So what you are required to do, spread to the right of what? The median. That's it. Or to the right of 42, you can say that. Some they may prefer to say there is more spread to the upper 50%. Because median, remember, is 50, 50. So to the upper 50%, that's it. Or to the top 50%. Now, question 2. Okay, now it says, the scores for 8 golfers who played a single round of golf on the same golf course are shown below. 69 to 69, 71, and okay, the numbers are not put in order. But since we are not required to calculate the median there, you don't need to worry about the order. Now the question is saying, calculate the mean score. Now, 2.1. So what we do there, mean is average. So the formula is even given on the formula sheet, if you forgot. Now, so what you need to do to calculate mean is x bar, like this, alright? So you add all the terms. That's why we summation of all the terms, xi all over n. You're summing all the terms. This means summation, yeah? Summing all the terms from 69 to 71, all of them, 69 plus 71 plus, and then divided by number of them. How many are they? 8, right? So if you sum all of them, what you get? You can punch in a calculator.
580.
What?
580.
580, that's it. Divided by how many are they? 8. Done. So what is the answer?
72.
Don't round it to say now you mean it's 73. Don't round. Leave it like that. You can round maybe to 2 decimal place, it's fine. But don't round it to whole number. Alright, that's it. Okay, now let's go to 2.2. Now 2.2 they say is calculate the standard deviation for the data. Standard deviation, alright? Now there's a formula on your formula sheet. You can use it, but it takes a lot of time in the Excel. So what you need, you can use calculator, you are required to do so. So you just need to know how you use a calculator, alright, when you're calculating this. So let's say you're using sharp, because for now I've got sharp. For Casio again, you go to mode, alright, mode you go to statistics mode. When you're in statistics mode, you punch on the statistics mode 1, alright. Now when we have done that, now you input all the data there. Like if you're using sharp, like what I said, you punch like 69 and then data. It will show you data 1. And then you go to 71, you punch 71, then data. It will show you data 2. Alright. Up until you punch all the numbers, you say data 3, data 4, data 5, up to data 8. Then from there now, you punch your, like if you're using sharp, alpha, and then there are small numbers which shows you which one to look for. Standard deviation is even actually given there also. So alpha, standard deviation, your answer there. You get your answer automatically. Okay. That is if you're using this one. If you're using sharp again, Casio, you do the same. And then you get your answer there, 2.78. Actually, the answer is 2.78388 2181. That is the answer that we're going to get for standard deviation. So two methods, you can either use your calculator or you can use the formula sheet, alright? And then you calculate it. Now from there, now the question 2.3 is saying, how many golfers scores lie outside one standard deviation of the mean? How many lies one standard deviation of the mean? So now what you do, we have got mean, we have got your standard deviation. But now the question is saying, how many lies outside the one standard deviation? Okay, 1, not 2, but 1. So what you do is 72.5 minus, now this we say it is 2.78, alright? Now 72.5 minus 2.78, because it's 1, you can say just times 1, it's one thing, alright? And then 72.5 plus 2.78. You deduct this, what you get? 69.72. And then here?
75.28.
So now, we have got these two numbers. Now we say, how many golfers lie outside? Alright, outside one standard deviation of the mean. Does 69 lie here? Does it lie inside? 69. Look at 69. It's outside, right? 71? Inside. 75?
Inside.
74?
Inside.
78?
Inside.
78?
Inside.
It's outside.
78 is outside. We want to see the numbers that lie outside this. So there is 69 and 78. So how many are they? That's what the question says. How many golfers lie outside one standard deviation of the mean? 2. It's common sense, eh? Only 2 lie outside the standard deviation of 1. That's the end of question number 2. Okay. Now let's look at question 3. It says here, a group of 8 learners was randomly selected from a class. Now the performance of these learners in a standardized test, which counted 1/5 marks, and the average number of hours they spent watching TV each week was recorded. Okay. Now the data is represented in the scatter plot below. Now check. These are 8 learners that were randomly selected. Alright? Now their performance is being measured against the number of hours that they were spending watching TV. Alright? So this number of hours that they spend watching TV. Alright? And then this is the test scores that they obtain. So it's increasing going there, number of hours, and also their test performance is going up. Alright? Now the question is, let's look at the first question. Now this is scatter plot. When you look at this, just try to understand the concept. Because now we are looking the tests that they obtain against number of hours spent watching TV. Okay. Now the first question is saying, what is the lowest test score for this group of learners? Now this is test score. This is number of hours that they spend watching TV. Now remember, test scores from 0, 10, going up, right? Now this one is 0, 5, 10, going there. So now, which one is the lowest test score? 30. Perfect. That is the answer for 3.1. So 3.1, the answer is that this is the lowest test score. Okay. Now the next question is saying, does the data display a linear, quadratic, or exponential relationship? Justify your answer. Now let's look at the graph. With the question in mind, let's look at the graph. Now, does this display linear, quadratic, or exponential? Linear is from line, right? Quadratic, you know the quadratic graph, how it looks like. Exponential, you know how it looks like, okay? So, looking at this, does they represent linear, quadratic, or exponential? And then you need to explain the answer, okay? So the first, it has got 2 marks, which means you need to state whether it's linear, quadratic, or exponential. And then you give a reason, 2 marks. Okay. So if you look at this, how they are doing, is it line? Does they show linear? Do they show quadratic? Or exponential? Now if you look at this, they show linear. That's the answer. And then why? Because they show sort of a line. Even if you were to draw a line, you will see it's going to be a line. Remember the scatter plot. If they were quadratic, they were going to show something like, okay. If they were exponential, something like, or, alright, but this is a line. That's why we say a linear. Okay, so linear because they show a line, they represent a line. That is the answer. Okay, so now the other question is saying, what conclusion can be reached about the learner's test scores and the average number of hours they spend watching TV? Now, what conclusion can you look at? Looking at this, what is your conclusion about their test, the marks that they obtain against the number of hours that they spend watching TV? If you look at this one, as you spend a lot of hours watching TV, the test score obtained is declining. That's what you do. So as the number of hours spent watching TV increases, the test that you obtain decline. That is the answer that you need to do. So the greater number of hours spent watching TV, the lower the test score. And vice versa, you can say the less time that you spend watching TV, the higher the score. You still get the same mark with the first statement. Or you can say there is a what? Correlation. there is a negative correlation between these two variables, between the test score and the average number of times paid. Simple and clear. Now let's look at the 3.4 now. Now it says another learner from the class watches 35 hours of TV per week. Using the given information, predict his or her performance in the test. Okay, so now let's go to our graph. Now if this learner watches 35 hours, remember, predict. So which means this learner is between this point and this point. Alright, so his performance is between 50 and 70. That's what he's going to get. We are predicting. Okay, so that's the answer, is between 50 and 70. Even if you just choose any number, you say it's 60. It's a prediction, it's fine. Or even if you say it's 69, but it should be between 50 and 70. You can choose any number. Remember, prediction, we are not saying you are exact only. We're just predicting, say it might be.